trail. A map of the trail is shown. His brother timed his ride from point A to point B. So question 1, what do the blue and red lines on this graph represent? And question 2, what type of triangle is formed by the red and the blue lines? We know that the trail is represented, or the path that his brother rode is represented by this red line. The blue lines represent the diagonals of the path that he rode. So the answer for number 2 is the red line and the blue lines make up a right triangle. How can you find the length of AC and BC without counting the number of units? In other words, if we're looking at segment AC, how can we calculate or find the length of this segment without actually counting each square? Again, how can we find the length of BC without counting every individual square? Number 4 asks, what are the length of these two blue lines? Again, without counting. And number 5, could we ever have a negative length? For number 3, how can you find the length of AC and BC without counting the number of units? Well, I know that A is 3, 4, and C is 7, 4. Therefore, I know that the length of this line, which is across the x-axis, is the distance between the two x coordinates. So from A to C, I know that it moved 4 units on the x-axis. So the length of AC must be 4. Then I look at B and I see BC, and I see that B is 7 and 9.5. The coordinates of C is 7, 4. Therefore, I know that the only change that was made was along the y-axis. So I look at what that change is. From 4 to 9.5, I know that we rose 5.5. So the length of this blue segment of BC is 5.5. You can do that by subtracting the x and y coordinates as well. If we looked at AC, we could take 7 minus 3 and we would have gotten 4 units. BC, we could have taken 9.5 minus 4 and gotten 5.5. Could we ever have a negative length? No. Distance can only be directional. So you can walk in an opposite direction, but you can never walk in a negative direction. For example, you can go 5.5 units to the right or 5.5 units to the left. But you can never walk, or in this case, he could never ride his bike -5 units. And the last question. Knowing the distance of AC and BC, how can we use the Pythagorean theorem to find the length of AB? To find the length of AB, which is the red line, we're going to use Pythagorean theorem by simply using the formula a squared plus b squared equals c squared. So I'm plugging in the length of AC, which is 4, so we have 4 squared. Then we have the length of BC, which is 5.5, so we have 5.5 squared, which is equal to c squared, our length of AB. Go ahead and update your table of contents in your notebook to the distance formula.